very cool assembly. That's right. So what we need to do is, you guys have worked hard, really hard, about learning about microgravity, learning about experiments, independent, dependent variables. I know. Learning about all that stuff, and you guys are gonna get soon, because I know a lot of you already have your experiment ideas, and it's time to start designing and writing your proposals. And one group in here's experiment is going to go into space. That is just awesome. Okay, here's the thing. What we looked through, when Mr. J, Ms. Fierro, others of us looked through the schools that won, that was all like, the Fancy Fan STEM Academy of Rich People Land, Pennsylvania. But guess what? You're now on the same exact plane as they are, because you are launching up with them. So can we get another woohoo? So, we have a really cool movie to show you guys, and then we are going to go into, meeting with Dr. Goldstein, the head of the program. Lights.
John Muir hosts, yeah. You need to go for launch. E1, are you go for launch? B7, are you go for launch? D6, are you go for launch? B9, are you go for launch? D4, are you go for launch? K7, are you go for launch? K4, are you go for launch? M2, are you go for launch? M6, are you go for launch? K6, are you go for launch? Hey, are you go for launch? Launch control, this is Corcoran. We are go for launch.
Hey, Dr. Goldstein, can you hear us?
Can you hear me?
Yes, we can hear you. All right, but I gotta ask these guys. Hey, lights up for a second. I gotta ask these guys a question here. Let me see if you can see all 730 of them that are in here. Okay, so these guys have been working really hard. They've done their background research. They are experts in microgravity. A lot of them already have their design ideas. Okay, and they are ready to get into the nitty-gritty design proposal, ready to hear from you. So I'm going to ask them if John Muir is go for launch. So you mind if I ask them that real quick? Okay, John Muir.
Go for what?
I'm going to see if they're go for launch into writing their proposals. So you mind if I ask them that real quick? John Muir.
Are you go for launch?
Okay, can you say John Muir is go for launch? Let's see. John Muir, you go for launch? I'd say they're ready to go, so I'm going to turn it over to you, Dr. Goldstein.
Okay, so can everybody hear me all right? All right, so I've got my jelly beans here. I always do a teleconference with jelly beans. If anybody wants a jelly bean, raise your hand. Here we go. Here we go. All right, so here we go. let me get a little serious now. Let me tell you what I wanted to talk about today. First, let me introduce myself. And by the way, my friends call me Jeff, not Dr. Goldstein, so you all can call me Jeff. And I'm the Center Director for the National Center for Earth and Space Science Education. And you are all part of the Student Spaceflight Experiments program. And I'm the guy who created that program. And I work with a team over here to work with 18,300 students across the United States and Canada on this mission. There are 31 communities participating, and Corcoran Unified is one of those 31 communities. So we're really excited and honored that you're part of this initiative. And I know that we've been working with your school district for a while to get you aboard, and it sounds to me like you're go for launch. And you need to know that we're go for launch as well. In fact, on the website, there's a clock counting down to the launch of the experiment that will be selected from Corcoran Unified to fly from Kennedy Space Center in Florida and be transported to the International Space Station in low Earth orbit, moving at 18,000 miles an hour, and have an astronaut assigned to operate your experiment according to your student flight team's desires to their protocol. So let me tell you a little bit about myself and give you a sense of maybe a personal view of what research is like. So my degree, it's called a PhD, is in astrophysics, and I get to study the universe. And maybe it would be good for me to tell you how I got there. You know, when students ask me where did I go to school, I always start off by saying I went to Little Red Train Nursery School. And I remember turning 5 in nursery school. And they're kind of surprised that I say that because they're expecting me to say what university I went to. But it's really important to tell students that all of us that you might look at as researchers on the frontier or successful professionals, we started out when we were younger than you. And we made decisions along the way, and we tried to figure out what our gifts and talents were, and we wanted to try to find a job that was something that we really enjoyed, as opposed to a job that just pays, you know, that gives you a paycheck. You know, a job that you enjoy, when the paycheck comes, you can say, I even get paid to do this. And that's what an enjoyable job is all about. So just to give you a sense of my trajectory, I went to Little Red Train Nursery School, and then I went to Smith Street Elementary School. And I graduated when I was in 6th grade, and this was in New York State. And I went to Castle Hill Junior High School from grades 7 through 9. And many of you participating in this program, I believe, are 6th through 8th graders. Isn't that correct? 8th graders. And then I graduated from junior high school, and I knew I really thought science and math was way cool. And I went to a high school called the Bronx High School of Science, and you graduate from high school in grade 12, and if you want to be a space explorer, a space scientist, you have to go on to college. And so I went to the City University of New York, and I got a Bachelor of Arts in physics. And that took me to grade 16, because it was 4 years as an undergraduate, so grade 12 at the end of high school to grade 16. But if you want to be a space explorer, you still have to keep moving forward and go to what's called graduate school. And then I went to the University of Pennsylvania, and I got my master's degree in astrophysics in grade 18. And then I went on to the PhD, the doctoral program in astrophysics, and I finished my coursework at grade 20. And then I started working with my friends and I on a very special machine called an infrared heterodyne spectrometer that had never been built before. And my teacher gave me the keys to a telescope on the Big Island of Hawaii, almost 3 miles into the sky, and he said, go play. And what I did with my friends, where we built this heterodyne spectrometer, we were able to use one of the most powerful telescopes on Earth and point it to planets maybe a few 100 million miles away, and measure gentle breezes of 2 miles an hour all over that planet so we could understand the winds of other planets. And so I'm sort of like an interplanetary weather guy. And I got my PhD, my final degree, and got out of school in grade 26. Grade 26. And so you're looking at somebody who's not crazy, because I stayed until grade 26, but somebody who absolutely loves being on the frontier and doing research and doing human exploration. And I can tell you that we were the first to measure the winds above the clouds on Venus. We were the first to measure the winds on Mars. And we even helped NASA get a spacecraft to the largest moon of Saturn called Titan, because they needed to understand the direction and strength of the winds on Titan. And we were the only team on planet Earth that was capable of getting NASA that critical information for mission success. So what do you think it feels like to help get a spacecraft to another world for the first time in history? It's like way cool. It's way cool. And I don't know, let's see, are any of you in sixth, well, I guess you are sixth graders. How many of you are 11 years old? Okay, so the reason I asked that is finding special schools. And let me say that the only difference between you and me, I want to be very clear here, the only difference between you and me is that I'm older, and I may have different gifts and talents and loves than you do. Because I like science and math, and not everybody's going to like science and math. But I can tell you that I have limited musical ability. That's not really a gift of mine to play a musical instrument. I don't draw very well, so that's not a gift of mine. And I'm sure many of you do far better in music and in art than I do. So we all have to figure out what our gifts and talents are. And I figured out what mine were, and I put them to work. And so that's, I think, an important lesson in general for students when they think about their future. But let me tell you that many of you may not understand what I'm about to say. And if you don't, ask your parents about this or some other adults in your life. But there are these moments in time that we experience as humans, as people, as individuals, that change us forever. There are these moments in time where it might be something very personal that happens inside our family. It might be something that the entire planet Earth gets to see, so that the entire human race experiences this. It could be something that's really, really sad. It could be something that's really, really amazing, very happy. And what I'm trying to say is that when these moments happen and we experience it and we let them wash over us, we are never the same again. There are moments in time that change us forever. And I was 11 years old when that first moment in time that I can recollect happened to me. And I remember that I was in a little town called Uniondale in a place called Long Island in New York State. And my parents were getting ready to move to the big city, to New York City. And I was sitting on July 20th, 1969, on a bunch of moving boxes in my living room, watching a small black and white television set. And on that television set, I watched a human being walk down a ladder, and for the first time in our history, put a footprint on another world. I watched Neil Armstrong put his foot on the surface of the moon. And I could go outside at 9 o'clock in the evening and look up at the moon 240,000 miles away and realize that there were 3 people up there. There were 3 people that went to the moon: Neil Armstrong, Buzz Aldrin, and Michael Collins. And I knew in that moment, when I was 11 years old, I wanted to be a space explorer. So when I was 11, I knew I set my pathway for myself, and for some amazing reason, I was able to succeed. Now, that's not to say that you need to know what you want to be when you grow up when you're 11 years old. I'm just telling you my personal story. And the important point is there was this moment in my life that I experienced that changed me forever when I saw Neil Armstrong and Buzz Aldrin walk on the moon. And I think the reason I want to tell you this story is that many, many, many years later, when I already was an astrophysicist, there was a principal in Reston, Virginia. Her name, by the way, was Gina Ross. And Gina called me up, and she said, "Hey, Jeff, can you come and talk to my teachers before the start of the new school year?" And you probably all know this, that your teachers typically come in for the new school year about a week before the students arrive so that they get their classrooms set up and they get their curriculum moving. So teachers start school a little earlier than you do. And so she said, "Can you come and talk to my teachers to get them really excited about learning and science and exploration?" And I said, "Gina, sure, I'd love to do that." And remember, she was the principal of Buzz Aldrin Elementary School. And so I went there a week before the start of school for the kids, and I talked to the entire teaching staff of Buzz Aldrin Elementary School, and I was telling them about what it's like to be an astrophysicist, what it's like to see things that no human being has ever seen before, because that's what it means to be on the frontier, to be an explorer. You're through your own work trying to see things that nobody's ever seen before. Then that gets into the textbooks. Everything that you read about in your books, in your textbooks, people had to discover those things. That was new information some time ago because somebody wanted to find out what was going on in that particular field. And so I was talking to the teachers, and I was getting really passionate and excited. Maybe I had too much coffee. And I was telling them about how I got interested when I was 11 years old. And I was talking about my heroes, Buzz Aldrin and Neil Armstrong and Michael Collins. And in the back of the room, the door opened very slowly, and it was a noisy door, so everybody could hear the door creaking open. And we looked back, and Buzz Aldrin walked in. The real Buzz Aldrin walked in when I was talking about my heroes when I was 11 years old. And what Gina Ross had done is invite Buzz Aldrin to his namesake school, Buzz Aldrin Elementary School, and she didn't tell me or any of the teachers. And so, as you can imagine, it was something that I was very nervous about this. I was just talking about my hero, and my hero just walked into the room. And so it was really hard for me to finish that presentation because it was hard to concentrate. And after it was all over, Buzz Aldrin and all the teachers went out into the hallway, and all the teachers were talking to him, and there was a big crowd around him. And I was trying to figure out what just happened. And I was packing up my projector, and I was packing up all of my equipment. And I went out into the hallway, and Buzz Aldrin was there. I saw him in that big crowd. And he saw me. And he made his way through the crowd really fast, and he came over to me. And he grabbed my hand with two of his hands, which was one of those two-handed handshakes. Let me tell you how that works. If somebody you don't know grabs you with two hands and shakes your hand, what he or she is saying is you've made some kind of connection to them at a deep emotional level. Because people don't simply extend two hands to a stranger like that just all the time. And so he grabbed my hand with his two hands, and he said, "Jeff, that was really inspiring. Where did that come from?" He must have asked who I was because he called me Jeff. I couldn't believe that he called me Jeff. He said, "Jeff, that was really inspiring. Where did that come from?" And I just looked at him, and I didn't know what to say. I didn't know how to think about answering him. I just said to him what came to mind. And what I did was I looked him right in the eye, and I remember swallowing hard. And I said, "It came from you." And the point that I was trying to make was that he inspired me to go places I never thought were possible. He inspired me. It's the game that we're all playing. Every generation has to inspire the next generation. Because that's how we all go to places none have gone before. And the reason that we created this program, the Student Spaceflight Experiments program, is to pass this forward from our generation to yours. We want you to go where none have gone before. And our feeling is that you, as 6th to 8th graders, are perfectly capable of being part of a real space program, America's space program, that you're perfectly capable of designing real experiments and going through the same proposal process as real professional microgravity researchers, and going through a flight safety review at NASA's Johnson Space Center in Houston at the toxicology office at Johnson, and are able to launch an experiment and analyze the experiment and report out results at a real conference at the Smithsonian's National Air and Space Museum. What we are immersing you in is the way research is actually done. And we're really proud that all of you are part of the Student Spaceflight Experiments program, whether you're students that are engaged in experiment design, or whether your students are also involved in the mission patch art and design competitions, because mission patches have been part of every spaceflight launch, human spaceflight launch, ever since NASA started sending humans into space. So the reason I wanted to tell you this story is to give you a sense of me talking to you in a very personal way and say, hey, look, I was once younger than you, and here's the path this researcher took to get to the frontier. That I was inspired when I was 11 years old by my heroes, Neil Armstrong and Buzz Aldrin. And because of that, I knew I wanted to be a space explorer, and I became a space explorer. And I had this wonderful moment when I was imparting my love of science and exploration to teachers a number of years ago, when I actually got to meet my hero and tell him face to face that he was the reason I am where I am. And that as a natural progression of what we're trying to do here, my generation is trying to inspire your generation to go forth and go to places none have gone before. And that's the reason why the Student Spaceflight Experiments program was created. So does everybody understand what I'm saying? So, should we take any questions, or do you have to move on to something else?
We're good for questions. Do we have any questions? Does anybody want to ask a question? All right, nice shade. Come on. What's your question? Just shout it out and I'll answer it. I'll ask it.
Mr. Whitmore can say the question over again so I can hear it.
Okay. No, you gotta do it louder. When was the SSEP created?
We created it in 2000. Well, the first mission was announced in 2010, so 7 years ago. And since 2010, about 95,000 students have been engaged in this program across the United States and Canada.
He wants to know what gave them the idea for you to measure things on Titan when you were doing your work.
Well, that's really kind of interesting. The spacecraft, in fact, which just ended its life last month, was called Cassini. And it was orbiting Saturn for a very long time, many, many years. But when it was getting to Saturn, it launched a spacecraft to go into the atmosphere of Titan, which is Saturn's largest moon. And that little spacecraft was called Huygens, and it was going to parachute through the atmosphere of Titan all the way to the surface of that moon. So the first thing to say is, yes, there are moons with atmospheres. Titan is the second largest moon in the solar system. It's bigger than our moon. It has an atmosphere thicker than Earth's. And we think that the conditions on Titan are what it was like here on Earth about 4 billion years ago. So by studying Titan, we can try to understand what Earth was like in the distant past. The problem, though, is that if there were strong winds in Titan's atmosphere, the little probe that was placed in the atmosphere could be carried by the winds to the side of the moon that could not be seen by the Cassini mothership. So if this is Titan, and let's say your planet Earth, here's the Cassini spacecraft. It is sending information by radio back to you. You can see it, and so that means that light or radio waves from the spacecraft can go to Earth. Now, the little entry probe, Huygens, that parachuted into the atmosphere, was sending information to the Cassini mothership, which was then sending information back to you on Earth. The problem is that if the winds on Titan were going around like this, if you put the entry probe, if you put the Huygens spacecraft into the atmosphere here, then the winds would carry it to the opposite side of Titan, and the Cassini spacecraft will lose contact with the Huygens spacecraft. But if the winds are blowing like this, and you bring it and you put the spacecraft into the atmosphere on this side, then the winds will carry it on the front side of Titan, always in communication with Cassini, and then the Cassini information could be radioed back to Earth. So NASA didn't know how strong the winds were and what side of the moon they should insert the Huygens entry probe. And so they were desperately trying to find some way to understand the strength of the winds and the magnitude of the winds. And we were contacted because they knew that we did wind measurements from Earth of atmospheres beyond Earth. And we were the only team on Earth that was able to determine what the strength and the direction of the winds were on Titan. And so that's how it happened. Does that kind of make sense? I tried to make it as simple as I could.
Excellent.
Guys were jelly bean.
Any other cool inventions that you can think of that you've made? Any other cool inventions that you've made?
That I've made?
Yes.
No, not really. I mean, the heterodyne spectrometer that my friends and I built was a pretty sophisticated machine. And for it to be able to measure winds, it needed to have a very special carbon dioxide laser system. And so I'm the guy who built the carbon dioxide laser system to measure wind. So I didn't build the entire spectrometer, I built one piece of it. And that really was the only new device I built in the context of my research career.
How long did it take you to get measurements from Titan?
Measurements from Titan?
Yeah, because that's a long distance. How long did it take to get the measurements?
Let's see, it's about 11 astronomical units, and depending on where Earth is in orbit, it's about an hour and a half. Hang on a second.
Okay, approximately how long will it take when the SpaceX rocket launches? How long will it take it before it's in space? How many minutes, seconds?
From Kennedy Space Center?
Yes.
Just a few minutes.
Okay. I have one more question. We got one more question.
What's the closest city to you?
Fresno? Well, Visalia? Hanford? Sorry, go ahead.
Remind me, Mr. Whitmore, are you in Southern California?
We're in the Central Valley.
So what is the closest big California city?
Fresno.
Fresno, and how far is it?
About an hour, about 43 miles.
43 miles? What's the next closest city?
Bakersfield.
Bakersfield.
What is?
Bakersfield.
Bakersfield, how far is that?
Same distance. 65.
60 miles.
60 miles? Did you say 60 miles?
Yes, 60.
Outer space, from where you're sitting, outer space is just as far as Bakersfield. To get to outer space, you just have to go 60 miles straight up. So Bakersfield is as close to you as outer space. Okay, outer space starts 62 miles up. So how far is San Francisco?
About 200 miles.
200 miles. San Francisco is more than 3 times farther from you than outer space.
If you've been to Bakersfield, Bakersfield is kind of outer space. All right. We have one last question. We have one last question. She wants to know time travel. Are you out of time? We have one last question. Is Mars the next logical planet we'll travel to? And about how long would it be before we'd ever get there?
I don't know if Mars is going to be there. Are you talking about humans?
Yeah, humans.
It's a difficult question to answer because there are lots of different aspects of it. Let me tell you this, okay? If you want to, if you happen to have a grandma that's a couple of miles away from you, and let's say your mom and dad say, we're going to go visit grandma, right? And so you get in the car, you're not going to worry about necessarily bringing food with you because grandma's only a couple miles away. You're not going to worry about maybe, being real serious about, oh, you're going to go to the bathroom fast because grandma's just a couple miles away and she has a bathroom. That's not a big trip, right? You're not going to pack a lot of stuff to go to grandma's house. But if you were to take a trip from California to New York, you'd be thinking a little bit different. You know that you'd have to be stopping for bathroom breaks and finding a place to sleep or changing drivers continuously. You would pack a whole lot of stuff with you to go to New York. Going across the entire United States by car is a lot different than going to grandma's house just a couple of miles away from you. Well, that's the same as going to the moon versus Mars. Going to the moon is like going to grandma's house. Going to Mars is like going across the United States. The difference between a couple of miles to grandma's house and going across 2,500 miles across the United States is the same as the distance to the moon compared to the distance to Mars. So one should really kind of ask the question, have we given up on the moon already? Shouldn't we be going back to the moon? Because we haven't been to the moon for decades now. There's a lot of cool things to see on the moon. And so maybe it makes sense to go to the moon first to really figure out the engineering and all of those things that are necessary for colonization close by before you go to Mars, which is really, really far away. If the astronauts have an emergency, say on the moon, you could have stuff to them within days. If there was an emergency and you needed to get to them, you could get to them in the course of days. If there's an emergency on Mars, there's nothing we can do for those astronauts because it takes 6 months minimum to get a spacecraft there. So, in my professional opinion, I would concentrate on going back to the moon first before going to Mars, but it's not as cool going back to the moon as going to Mars for obvious reasons. And so I'm not sure that the way that America will move forward is indeed going back to the moon first. But they're fundamentally different trips. So the best I can do with a rather short answer. There's a lot more complexity to that answer, but I think that pretty much covers the basics.
All right, perfect. Okay, we have taken enough of your time. We're going to say thank you. Okay, everybody, we're going to say thank you on the count of 3. 1, 2, 3.
We're looking forward to getting the 3 finalist proposals and selecting the student team that is going to represent Corcoran Unified School District on the International Space Station in outer space.
Thank you again. Mr. J. All right. We had our mission patches contest. And first we're going to show you the top 5 mission patches from the elementary schools, from the Bret Hart Tree Huggers. I know, Bear Huggers. Mrs. Hawes is getting ready to throw something at me. The Tiger Cubs of Fremont. And the Eagles of Mark Twain. Ultimately, the winner from the elementary schools was Miss Lumide Negrete from Mark Twain. Here were the other top 5. We had Joshua Andrade from Fremont. We had Halen Serrano from Mark Twain. We had Alejandro from Fremont. We had Miley Sweat from Fremont. Now we're going to go to the top mission patches from John Muir Middle School. And we have our winners that are going to come up here. Okay. All right. We have Faith Perez. We have Rosie Correa. We have Sierra Ortiz. We have Grace Keandre. I saw back there somewhere. Keandre Stevens. Stand up, Keandre. And our winner, who could not be here today, and his patch is going into space, Mr. David Oscar. We have, oh, here they are.
It's amazing.
Cool things for you. Huge round of applause for everybody, but especially our finalists. Thank you, guys. All right, huge round of applause, everybody. Hey. now we are going to start our dismissal back to class. We're going to go back to period. Wait! Stay seated. Mr. J is going to dismiss from that side. And Mr. Weezer is going to dismiss from this side. But stay seated. And time already.